Okay, guys, so welcome to the Week 10 class. I'm going to kind of keep this one relatively short and sweet. It's one of those where there's a lot of common sense involved. Next week, we will actually be moving on to the more statistics part of data analysis. And with that, I will probably do a lot more kind of writing. But what we're going to do this week is I'm just going to kind of go through the slides and make, I think, what a few important points and maybe give you a few examples. And then I'll give you an introduction to SPSS. As I said, the practicals, I want you to kind of work through them. I want you to, learn how to use SPSS for your project. So this is really just a guide to get you going. So I'm going to go through SPSS with one data set, and then you'll have the practical exercise online to get some practice with a second data set. So this week is all about the preparation of data, which is a fun and interesting subject. Okay, so in my kind of commercial life, I've dealt with lots and lots of data. Data from spreadsheets, data from databases, data from statistical packages, and data quality and data integrity is very, very important. I've told you before about, experience with CRM systems where you get salespeople just entering a load of junk into the systems. And one of the first things I did commercially was to build up a CRM system, and it had salespeople previously had like spreadsheets and pieces of paper and little access databases and put it all into one system. And that was very, very, difficult because we had this inconsistent data from lots of different data sources. And to try and get it into a consistent format was very, very difficult. Now, let me just give you a bit of an aside, is when you're dealing with data and you have an error, if it costs you $1 to prevent the error and to look through your data for bad quality data, if you don't do that, it could cost you $10 to correct it. And eventually, if that data leads to bad decisions, you'll get a failure cost of $100. So it's like really, really important to actually deal with bad data. So I've kind of given you some examples before. So you got this little Dilbert cartoon for you. So corporate data can be of very bad quality. We could have multiple versions of the same account, have lots of out-of-date information, missing fields, and again, problems with merging data. And all this stuff you're going to be doing over the next few weeks, which is mainly statistics, that stuff's pretty much useless if you have bad data. So survey data, and again, I'm just going to, this is kind of like common sense. There's lots of different ways you can go about data. We talked about non-response bias, this idea that, we're paying people money to do the survey and it's really long. We're going to be really biased and get lots of people who are kind of money poor, but relatively time rich. So if we're doing something like, a survey of social habits, we're going to get really, really biased results. And I talked to you about how we did this before. One standard way of doing non-response bias is we'll take the first kind of 25% of respondents, take the last 25%. We'll assume the last 25% are close to non-respondents, and then we compare the first and last 25%. And if there's a big difference, then we'll possibly have some non-response bias. We also have missing data. Now, missing data can be problematic. Different reasons for missing data. Maybe we just have a really long, boring survey, and if it's person administered, people just drop out after it. We may have some bad data. We may have confusing questions. And on the whole, this is just best learned by practice. Just lots of practice designing surveys, looking at the problems you encounter when you do surveys, and trying to kind of incrementally improve your surveys. I found this. This was actually from a CIO. And if you don't know, a CIO is a Chief Information Officer. And they were saying here that these are reasons. This was a survey of leading CIOs, of the top people in IT. And this is kind of why we want to maintain a high quality data strategy. It makes us a lot more efficient. We're not running around after bad data. Improves customer satisfaction. If I can give my customers nicely tailored emails, if I've got their right address, if I know something about them, I have up-to-date information, it makes the process of customer engagement a lot more easy. We can make more informed decisions if we have a true picture of what's going on in the company. And again, if we have good data, as it makes everything more efficient, makes our marketing more efficient, we can save a little bit of money. And what are the most common errors? We have missing incomplete data. Our data is out of date. You know, I told the example of the salespeople repeatedly entering the same information, duplicate data, and also inconsistent data. Maybe we have one record saying this person has $5,000 of business with us, another record saying they have $3,000. Which one's correct? And this one's actually from a UK source. And so it's like a little, your supply chain people might like this. It does it as like a little machine. And basically, if we have missing data, outdated content, and about 50% of companies have those problems, and about 90%, nearly 90% think they may have at least some accuracies in the data. And if we've got this problem, then the majority of companies waste about 14% of revenue due to bad data quality. Okay, so we're not going to go too much into this. This is like almost a template for the next few weeks. This week, we're going to be looking at getting your data, validating your data, putting in a statistical package. So we look it, we edit it, we code it, and we enter it. Again, with this book being a little out of date sometimes, most of this stuff is done automatically, but it basically is a good idea to know the basics. And then the final thing we're actually going to do today is we're going to tabulate the data. We're going to put the data into what we call 1- and 2-way tables. And then data analysis is what we're going to be doing in next week and the week after with your favorite subject, statistics. Okay, so this kind of goes through some of the stuff we've covered before. We've already kind of covered curbstoning, this kind of falsification of the data, which may be some sort of issue. And the idea of validation is we can kind of try to validate the data and look for errors in these different areas. So we can look for fraud, we can do data screening, we could look at the data collection procedure, we could look if the data is complete, and then we can look for something called courtesy bias. Okay, so examples of fraud. I think I already gave you this example earlier in the class, so we won't do more about it. We can have we talked about in the first few weeks fraud from either the interviewers or the respondents. I know that when I'm clicking on YouTube and I have my little survey pop up, I will just click the thing that makes the survey go away quickest. So in that way, I'm a fraudulent respondent. And we gave the example. Do check out this article. It's quite an interesting article, and play a little bit around with FakeSpot. There's a lot of kind of fraudulent information out there. So screening. We kind of discussed this. We've discussed this a little bit before. We implemented it in Qualtrics. So, you know, again, have you ever lied about your age to get into a cinema, bar, etc.? Now, you're not in front of me at the moment, so I can't ask you to raise your hands, and then we can have a bit of a laugh and see who's honest to who's not honest. but maybe we could possibly validate this information. If somebody says they're over 18 and we have some sort of records we can validate, that's maybe one thing to look at. We've got, if we've got people's credit cards, we've got the online IDs, we can cross-match, we can actually begin to check some of this stuff. And in an in-person interview, that's probably going to actually be a little bit easier. We could check their ID. We could look a little bit about their answers. Do we have a good procedure? So the data set we're going to do in a minute is a kind of a fear of statistics data set. And what we happen is before an exam, we measure people's heart rate, and after the exam, we measure people's heart rate. Now, we have to do that within 10 minutes, otherwise the heart rate will go back to normal. So if you have some kind of lazy person and they're measuring an hour before the exam or an hour after the exam, then this is kind of a very poor process, and it's not going to meet the standard. Another example, so we had do an intercept survey on retailer experience. The idea is that somebody comes out to a retailer, they've got the experience fresh in their mind, we grab that person and we interview them. But again, we might have a lazy interviewer who says, I can't be bothered going around the shops. They just go to the bar in the evening, sit with a drink, and then interview people sitting at the bar, which again is very, very poor. So there's a poor procedure. So that's one way of validating, is to look at your interview procedure. Why isn't our data complete? Lots and lots of reasons. We could just, again, by going back to my friend, the lazy interviewer, we may just kind of not do the survey correctly. We may not ask the proper questions. We may have this badly designed, long, convoluted survey that has a large dropout effect. Online, we can kind of force completeness, but again, we still may have just a dropout effect. So we need to think a little bit about completeness of our data. And courtesy. When we're doing, this is more for kind of in-person interviews. If we've got our interviewers, they should be, I said a lot of this chapter really is common sense. They should be as biased as possible. They shouldn't try to force answers. There should be a level of courtesy and professionalism. And again, we have to be aware of something called courtesy bias in this kind of context. If, for example, I was to ask people, what do you think of my company? And I'm dressed in the company t-shirt, to be courteous to me, I may think you're like a terrible company and I would never go anywhere near any of your stores if they were the last places on earth. But I might just respond, well, I'm kind of neutral. So there is that degree of courtesy bias there. Okay, so once we get the interview information, online surveys is all very nice. It actually just will all be online already. But if we have interviewers and respondents, we're doing offline surveys, we need to make sure that the data is correct. If it's a recording, we need to make sure that it's properly transcribed. We need to be sure that things have been filled in correctly. And then finally, we get into the data entry. And again, this is more of a practical task. It's just getting the data, putting into the software, looking for errors, looking for missing data, and just organizing your data. And this is what we're just going to do it. I don't expect you guys at the end of this class to be data wizards. You're not, on the whole, IT majors. I think any data skills are good. But this class, we've really just got to restrict ourselves to the basics. We can't do incredibly complicated, routines. Okay, so we have our data set, and our data set is this data set on fear of statistics. Okay, so we have, this is the Mississippi State University Information Services kind of website. So just go to Mississippi State, go to the software site. Just if you can't find it, just type in Mississippi State software and you'll get this. And under this is all the software you can get from our university. And you can see here that we have IBM SPSS. So if you don't already have this installed, then you can get these are pretty comprehensive instructions. So we've got, student use is basically, it will tell you to download the software. You can pick for Windows, or you can pick for Macintosh, and just kind of follow the instructions, and you should be able to get SPSS. And once you have SPSS, just kind of double clicking on a data file, SPSS data files have the .sav extension, will get you the data file. So this data set here is called Fear of Statistics. Now, I will just demonstrate it in a minute. So you have two views. You have the data view, and if you notice, this is just a lot like an Excel spreadsheet. You've got your variables along the top, and then for each item, each of these items is a student, you have entries for every one of these variables. This is the data view. The second view is the variable view, and it tells you a little bit about these different variables. And you can kind of see, for example, we have gender, the type. So gender is actually a number. We have genders 1 and gender 2. We have the major 1, 2, 3, 4, 5. And then we have the reason. This was like the reason for taking the class. Now, these on their own don't mean very much. And this kind of gets into our next section, which is data coding. But first, let's actually just add a new variable. We have the math quiz. Now, this data set is basically a load of students. They're taking a math and stats classes, and we want to know kind of, how fearful they are of the subject. So we have a lot of what we call kind of covariance, things that might influence this. We have the gender, what major they're taking, the reason for taking the class, the experimental condition. I think this is how hard the test was, the amount, whether they drink coffee or not, the number of cups of coffee that they drink in a day, whether they actually have phobia. We have some maybe psychological scale of phobia or fear of statistics, their previous math experience, what they scored on the test. Then we have some measures of heart rate, the heart rate they had before, their base heart rate, the heart rate directly before the exam, the heart rate directly after the exam. And we have some sort of, again, some scale anxiety test, very similar. And we measure their base level of anxiety. So this person here is obviously a very generally anxious person. And then we can measure it directly before the test and also directly after the test. Okay, so let's kind of go back to this. And this brings us on to data coding. Now, there's two types of coding we're going to talk about. And the first is these numerical variables, these numbers here. They don't really mean very much. They are generally either gender is a nominal variable, major is a nominal variable, kind of maybe the previous math experience is an ordinal variable. We rank people, how much math experience they have. But at the moment, we can't really do an analysis on this. So let's go to gender. Now we click on the values and we can see that we actually have a coding here. We've coded the variables. So we've coded 1 as female and 2 as male. So let's actually remove that and click OK. So let's now do it from scratch, and let's kind of go back again. Okay, so we have the gender here. We're going to click in the value of 1, and we're going to give it a label of female. Then we're going to add, and the value of 2, we're going to add male, add, and then going to click OK. As simple as that. And again, we have some slightly more complicated ones here. Here's the major. So Again, this is a simplified data set. We have 5 majors taking this in this experiment. We have psychology, pre-med, biology, sociology, and economics. And also we have why they're taking, program requirement, personal interest, our advisor recommendation. And then this is how hard the test they're given. I'm pretty sure that if I did this with you guys and gave, a quarter of you each of these different types of tests, I'd probably be breaking some sort of university or even federal guidelines. But okay, so one last thing, we can actually create new variables. So at the moment we have the math quiz. This is between 0 and 50. Now generally students I know like their exam scores to be on a scale of 0 to 100%, otherwise they can get confused. So let's create a new variable. So let's go to transform, compute variable, and our target variable, we're going to call it math quiz 100. And then we're going to set equal. Now we have the existing variables down the left-hand side, and we're just going to double-click math quiz, and we're going to put in multiplied by 2. So we've got math quiz 100 equals math quiz times 2, and we're going to click OK. And you can see this here is SPSS just working. And now if we go, we should have a math quiz 100. Now notice here that we actually have 2 decimal places. Since these are all whole numbers, I don't think we need these. So let's go back to variable view. And let's make math quiz 100 like the others. We're going to have it width 11, and we're going to have 0 decimal places. And then it's going to be exactly like all the other variables. Okay, so what we've got our data into SPSS now. And we'll just kind of, what we want to do is we want to start, summarizing this data and showing some kind of graphs. Okay, but before we want to kind of, talk about the graphs, there's just a few other little things that I want to kind of talk about. And the first of that is going to be data coding. And we've already given the example where we did the data coding and we showed it for the qualitative variables. But imagine if you have like a free response. You have an interviewer and you say, what's your favorite supermarket? And people will actually say their favorite supermarkets. You have textual data. So quite often what you would have to do is you'd maybe have 30 or 40 different supermarkets. You'd have 4 or 5 main ones, and then you'd have some really strange, bizarre supermarkets you've never heard of. What you would do is you would code 1, 2, 3, 4 as your main supermarkets, maybe Walmart, Kroger, Publix, Quick Save or something, and then have 5 as others. So there is, if you have textual data, if you have non-quantitative data, there is a little bit extra to the coding, which in a way, dealing with very unstructured data is maybe a little bit beyond the class. So we also have the problem of errors and what happens. How do we actually try to find, errors? Well, there's certain things that we could look at. We could look for perhaps, typos, spelling mistakes in textual data. We could actually print out a summary of the data and just look at the data and see if it seems reasonably sensible. We may have a question where the categories are a little bit wrong. We may have a question where all the answers are not what we expect. So we may want to just kind of preview the data, have a summary of the data to look for possible errors. Now, missing data is difficult. When we deal with missing data, there's actually some very complex statistical ways of dealing with missing data called statistical imputation. Again, a little bit beyond what we're going to be covering in the class. But quite often, there's simpler ways of dealing with missing data. Either we ignore the missing data or we replace by the mean value. Now let's have a look at SPSS at some missing data. SPSS, if you have missing data, it's just kind of, it's got a dot there rather than a number. So for the moment, most of the routines in SPSS can deal with missing data. So for the moment, we're just going to ignore missing data. But there are ways, basically imputation, what it does is it tries to find the distribution of the data, and then based on that distribution of the data, it tries to plug in numbers that seem relatively sensible. But for the moment, we don't have much missing data here. Just be aware in practice that this may actually be something of an issue, or maybe something of kind of a problem. Okay, so next we're going to move on to dealing with graphical information. So let's just kind of run here. Okay, so what I've got here is I've just given you some kind of, it's a little bit silly, but it's actually it's kind of there's a point behind it. I'm just kind of going to show you some example graphs and show you kind of how not to do graphing in data analysis. And then we're actually going to do some graphing and data analysis in SPSS with our data set. So first things first, why is this graph bad? This is running an experiment. We have this is kind of a behavioral experiment. We have basically two variables. One is therapy and one is something else. Maybe it's a certain drug or not a drug. And it's a 3D graph. It's people have chosen the most complicated graph possible. It's got confidence intervals there. Nothing is really very clear. It's hard to read exact numbers. This is exactly the same graph. We're measuring thought in 2 dimensions. And you can see that is a lot clearer. So a general rule is 2D graphs are better than 3D graphs. So here's an interesting one. This is for pie charts, which are used to show proportions. And this, I try and keep my class politically balanced. This is not getting anybody in particular, but this is just a very bad graph. A pie chart, everything needs to add up to 100%. It's showing proportions. But what they did is they said, we have an approval ratings. Do you approve this candidate? Do you approve that candidate? Do you approve the third candidate? And basically then they tried to put that in a pie chart, but there's some people approved of more than one candidate. It doesn't add up to 100%. So you just end up with a nonsensical graph. Here's another one. This is from the UK. And this is a pie chart. But again, there's too much clutter here. It's just, they try to make it fancy, but it's very hard to read. Another bad pie chart. There's just too many categories here, and there's too many very small categories, and we can't differentiate. I don't know the difference here between Turkey and Ghana because they're pretty much the same. So an idea here is you might want to kind of cut down and have a few more countries in the other section. Again, this is an Excel graph. This is somebody who's just gone to Excel and done the fanciest graph possible. A simple 2D graph would have been much better here. Same again. This is even worse. You can't see some of the data behind the front data, so some data is completely hidden. Now, this is interesting, thinking a little bit about scale. There's no right answer here. Do we want, relative scale or absolute scale? To get an overall view of something like on a ratio scale variable, in this case house price, you really need to have a 0. But having the 0 is it's hard to see the difference in house prices here between 1998 and 1999, as the gap is probably just so small. But however, if you do a relative, you can see the difference, but you can't see the difference to the overall cost. Now, this is good. This is a kind of a political advert. And notice that The first one is relative because it goes up from 28 point. This is a good thing. Employment's up, but we just show it like from 28.8 million to 29.9 million. And the second one is absolute, saying, hey, we've got the deficit down from 11% to 7%. So based on whether it's a good or a, we want positive or we want negative, we've actually changed the ratio kind of scale of things depending on our actual variable. So if you have two variables very close together, we've kind of spread them out, but the one that's gone down a third, we don't need to do that. Okay, so let's go back to our data set and let's go back to SPSS. Let me just catch up with my notes. Okay, so SPSS has something called Chart Builder. And Chart Builder actually allows you to create different graphs. So let's kind of go through this and let's just do some graphs. So you go to graphs and you go to Chart Builder. And this is relatively new. So SPSS has lots of other graphs hidden away, but this is kind of, a feature to put a lot of different types of graphs together. So if you go here, on the top you have the variables. These are the different variables we can put in the graphs. At the bottom we have all these different types of graphs, and each of these major categories has multiple subcategories of graphs. So let's start off with a histogram. You should be remembering all of this stuff from Business Stats 1. And let's just choose a simple histogram. So we just double click the first, we've got histogram, we double click the first item. Now we notice in our kind of top box here, we have some various different values, various different variables. Now, the first we have, let's just say we want to get an over idea of the distributions of our quiz results. We're going to put Math Quiz 1 in the x-axis. And it's a histogram, we don't need a y-axis. And we're just going to keep all our options as default. And we're going to click OK. And there we go. We can see the distribution. It's not quite normal. We can see the majority, the modal value is kind of around 62, 64. So obviously this quiz has got a spread. You've got a few people getting around 20. And you've got scores around, a few scores between 90 and 100. So let's go back to the histogram. And let's just do one that's a little bit fancier. We can actually group it by major. So we go to histogram and we now click the second one. And this time we've got kind of stack set color. And let's just do it by major. And here we go. We can look at the distributions by major. But to be honest, this is just a bit, you can see, for example, there's no real pattern here. We can see, for example, that there's quite a lot of low-scoring biology majors. Pre-meds seem to be scoring reasonably well. But on the whole, I would never show that graph to the client. It's a bit of a dog's breakfast. Okay, so let's go back. And let's now go to a frequency polygon. So let's go back to graphs, chart builder. This is the third one. And this is kind of just, we already have the Math Quiz 100 here, so we don't have to drag it. This is just showing kind of a discrete distribution, kind of putting it into a distribution. So we can see the overall distribution of exam scores. And no, I don't want to tell you what I think. Okay, so we're going to do what's called now we're going to do something called a population pyramid. So let's go back to our data. So this is the fourth one. Now, population pyramids are called this because it generally had the size of the population, and you'd have the different age groups, and then you'd have male on one side and female on another side. So you could see maybe gender imbalances and imbalances by age. But it doesn't necessarily mean this. But let's just have a look at the distribution variable. We're going to say this is, again, it's going to be Math Quiz 100. And our split variable is going to be gender. So we're going to look at the math quizzes by gender. And we're going to click OK. And we can see here there's not much difference. On the whole, females are doing a little bit better, but there's no great difference. But if you're looking, maybe say you're looking to see if males or females are better inclined towards your product, and you have some idea, brand satisfaction or brand approval, or even whether you've heard of the brand, then you could maybe do this graph to see if there's any difference between males and females. Okay, so next we have box plots. So again, this should be taking you way back in time to your stats 1. Or this should be taking you back to middle school, box plots. Okay, so box plots are intended to show distributions of variables. So let's just do it, and let's just have a look at, this time we're going to have the math quiz on the y-axis. And we're going to look at the distribution of the math quiz scores across the reason for taking the class. And if you recall, the box shows in the middle is the median. Then we have the 25th percentile and the 75th percentile at the edges of the box. This is just like when we calculated the median, we calculated the middle value. The 25th percentile is we're calculating the variable a quarter of the way along, and the 75th, kind of the 75th percentile along. We also have the whiskers, which is the lowest and the highest values. Sometimes the whiskers only show values that are within. This guy, the length of the box is called the interquartile range. And sometimes if the variables are further out from the box than 1.5 of this, they'll actually be noted as outliers and they would be out of the whisker. So that would actually depend. There's different ways of drawing these box and whisker plots. So we can get even more fancy. So we can now do a clustered box plot. And again, this is just adding an extra variable. So now let's do it by cluster by gender. So we've got gender, we're going to cluster on X, click OK. So it's the same that we had before, but, here we see we now have an outlier here on this, but we're actually looking for by gender. So we've got different distributions by gender. So let's go back to the original. We can see that the people who took a stats class, math class for personal interest generally do better than the people who take it because they had to take it. That makes sense. Though, there's no, this plot just gives us an idea. It doesn't show us any kind of actual statistical significance. Okay. So next we're going to move on to scatter plots. And scatter plots are used for showing relationships between variables. So let's go to Add to Graphs, Chart Builder. And we're going to do a scatter plot here. So let's just go to scatter dot and let's just start off with a simple scatter or a simple scatter plot. Now let's just have a look at let's just have a look at two heart rates. Like there should be, generally some people have, high heart rates, some people have low heart rates. So the heart rate between pre and post taking an exam should actually be relatively well correlated. So we have the heart rate pre and the heart rate post. So again, just double click on simple scatter, heart rate pre, heart rate post. Doesn't really matter which way round it is. Click OK. And here we have the scatter plot, and we can see the relationship. We'll talk about this next class, but they're correlated, which means that one goes up, the other one goes up. Now we could double click on this, and we can see that there's this kind of correlation here between the heart rate pre and the heart rate post. So what we can do is we can actually add a little bit of a fit line to this. So we can go add fit line at total. And we could add a linear line and apply. And you can see it actually fits. We'll talk about this next class. It fits a regression line. So you can see you can actually build the relationship that the heart rate post, the kind of the expected value is going to be 0.5 of the heart rate pre plus 36. So we can actually build a statistical test, a regression on top of this scatter plot. Okay, so the next thing is scatter plots. So we're going to show a scatter plot here. And we're going to show a scatter plot matrix. So let's go to graphs. Let's go to chart builder. And the scatter plot matrix allows you to look at lots of different variables at once. So let's actually look at 2 of the heart rates, 2 of the anxieties, and let's look at the math quiz. And basically with the scatter plot matrix, so let's just do this again. Scatter plot, this kind of the four windows is a scatter plot matrix. Let's select 5 variables and put these into the scatter plot matrix and click OK. And you can see here, now you can see, for example, that the math quiz score is not really correlated with any of these measures. You know, some people have naturally high heart rates, so there doesn't seem to be a big kind of relationship between math quiz and heart rate. But if we look at, say, for example, the anxiety, we can see the base anxiety is correlated with the pre-anxiety. And we could also see that, for example, the heart rate pre is correlated with the heart rate base, though not quite as strongly as the anxiety. So literally, this allows us to show lots of different scatter plots. And particularly when we move on to regression, and we want to look at relationships between lots of variables, this can be useful. But just be careful. Don't put too many variables in one of these things, otherwise it rapidly becomes unreadable. Okay, so the final thing we're going to talk about is data tabulation. And just a hint, I usually ask at least one question on the exam. Now, this is kind of really, really simple. One-way tabulation is we summarize variables by one categorical variable. A cross tabulation or two-way tabulation is we kind of summarize by 2 different variables. So one-way tabulations, we can just look at, you know, the responses. We could look at in each category, and we could also look at the missing data, and we could look at the non-responses. And let's just do this. So let's go back to SPSS and let's have a look at what we get with a one-way tabulation. So let's go to Analyze. Then we go to Descriptive Statistics. We go to Frequencies. And we're going to look at the reason value. And what this does is it allows us, the frequencies tab just allows us to summarize the data. Now let's click OK. And let's look what we get. So automatically it tells us that we have 100 items and we have 0 missing. And for each of our items, it tells us the frequency, how many we have, and what percentage of the data set it is. As we have 100 items in the data set, all these values are exactly the same. It also tells you the cumulative percentage from the first category, But if this is a nominal variable, it doesn't make much difference. But let's just say, let's be a little bit sneaky. Let's go to reason and let's remove a couple of these and make them missing. Then let's do analyze descriptive statistics frequency, same as before. You'll now see that we have 98 valid and 2 missing. So that is a one-way frequency table. Okay, so what use is a two-way cross tabulation? So let's just do this now. Let's go to analyze descriptive statistics. And we're going to do something called crosstabs, and this is just basically SPSS, how we do a two-way cross tabulation. And let's just kind of look at the major and then the reason. And we're looking for relationships between the variables. And click OK. And you can see in the columns we have the reason, and on the rows we have the major, and then we can look at the interaction of these. So we could say, look at, for example, psychology. Nearly 19 took it, most people took it as a program requirement, but only a few people took it as personal interest. But look at sociology, obviously it's not required for sociology, this class. So most people took it for personal interest or advisor recommendation. Now there's obviously some relationship here between the reason and the major. They're not independent of each other. And then I was going to ask you in class, what test would we do to show this? And I'd have maybe one person put their hand up and say, chi-square test, which again is what we're going to do in future weeks. So that is the two-way cross tabulation. Okay, so let's finally, to wrap this up, let's do a little bit of descriptive statistics. So look at some kind of summary variables. So let's go to analyze descriptive statistics, descriptives, and we're going to select heart rate pre. And then we're going to click OK. And on the heart rate pre, you see we get there's 100 of these things. They range from 62 to 87. And we also get the mean and the standard deviation. This is what we mean by descriptive statistics. So we get some, basic descriptives about, the heart rate. So what we could actually go back doing now is let's go to analyze descriptive statistics, descriptives. Let's just kind of calculate these 3 heart rate variables. And let's just see if there looks to be a difference. So we can see that the heart rate pre generally is the highest heart rate. Maybe people are anticipating the test. It's higher than both the heart rate base and the heart rate post. Is it statistically significant? Well, we'll talk about in the next couple of classes. We will actually find this out. Okay, so that was just, I try to keep this relatively simple. I said a lot of this chapter is a very small chapter with common sense. And in fact, when I teach it in class, I would take the entire second class to go through SPSS and the SPSS, have you do the SPSS exercise. Next week will be a little bit more involved because we'll start getting to the statistics and I'll do more kind of writing on that. But just enjoy your kind of relatively short lecture this week. And I will kind of email you about all the setup of the office hours and stuff like that.